In 50 AD, a Greek engineer built a functioning steam engine. It spun. It produced rotational force. The mechanical principle was identical to the engines that powered the Industrial Revolution 1,700 years later. The Roman Empire had access to it. They had the iron foundries, the aqueducts, the engineering expertise, and the trade networks to scale it. They didn't. The engine sat in Alexandria as a curiosity. The engineer who built it was celebrated as an entertainer. And the technology that could have industrialized the ancient world disappeared with the empire, leaving humanity to rediscover it from scratch in 18th century England. The question historians have spent decades arguing about isn't whether Hero of Alexandria built a steam engine. It's why the most powerful empire in human history looked at it and walked away. Hero of Alexandria was born around 10 AD in Rome and Egypt. By any measure, he was one of the most gifted engineers who ever lived. He invented the world's first vending machine, a coin-operated device that dispensed holy water in Egyptian temples. He built automated theater sets that moved scenery using rope, pulleys, and counterweights. He designed programmable carts, vehicles that could follow a predetermined path using a system of pegs and rope coiled around axles. 2,000 years before the computer, Hero was writing programs in rope. But his most significant invention was something he called the aeolipile. The design was straightforward. A sealed metal sphere mounted on a pivot over a heat source, two curved nozzles extending from opposite sides of the sphere. Water inside the sphere was heated to steam. The steam escaped through the nozzles. The escaping steam created thrust. The sphere spun. It was a reaction turbine. The same thermodynamic principle James Watt used in 1769. The same principle that powered every steam locomotive, every factory floor, every textile mill of the Industrial Revolution. Hero demonstrated it publicly. It worked. He documented it in a manuscript called Pneumatica, a technical text describing dozens of mechanisms powered by air, steam, and water pressure. The manuscript survived. The technology didn't. To understand what was lost, you have to understand what Rome actually had. The Roman Empire at its height controlled territory from Scotland to Mesopotamia. It had an advanced road network spanning 250,000 miles. It had sophisticated iron foundries capable of precision metalwork. It had aqueducts moving millions of gallons of water daily, the same water pressure Hero's device required. It had trade routes connecting 3 continents. Roman engineers had already mastered water wheel technology for milling grain. They understood gearing. They understood load transfer. The leap from Hero's spinning sphere to a functional mechanical engine was not a conceptual leap. It was an engineering refinement. Historians who have modeled the Roman economy estimate that a functional steam engine applied to Roman mining operations alone would have increased metal output by a factor of 10. Applied to agriculture, it would have freed an estimated 30% of the labor force. Applied to maritime transport, it would have reduced crossing times across the Mediterranean by more than half. Rome had everything it needed to industrialize. It had the water, the metal, the engineering knowledge, the infrastructure, the capital. And it had the machine, sitting in Alexandria spinning for crowds for 400 years. If the idea that the ancient world had this and walked away keeps you up at night, subscribe. Tech They Buried goes this deep every single week. The standard academic explanation for why Rome never industrialized is simple: slaves. At its peak, the Roman Empire had between 10 and 15 million enslaved people, roughly 20% of the total population. They worked the mines, the farms, the quarries, the construction sites. Every function a steam engine could have replaced was already being performed by human beings who cost nothing beyond their maintenance. From a purely economic standpoint, the argument holds. Why invest capital in developing mechanical labor when biological labor is cheaper and already available? But there are historians who find that explanation insufficient. Because Rome didn't just fail to develop Hero's engine. It failed to develop any labor-saving mechanical technology during a period when its engineering sophistication was unmatched in the ancient world. Kyle Harper, a historian at the University of Oklahoma who has written extensively on Rome's economic collapse, argues that the slave economy didn't just make mechanical development unnecessary, it actively discouraged it. Landowners and mine operators whose wealth depended entirely on the productivity of enslaved labor had direct economic incentive to ensure that no mechanical alternative emerged. In other words, the people with the capital to fund technological development were the same people whose fortunes would be destroyed by it. Hero's engine wasn't suppressed with a policy or a law. It was suppressed by economic structure. The incentive to bury it was built into the system itself. The result was identical to a deliberate suppression. The technology existed. It worked, and it went nowhere. Hero's Pneumatica survived because copies were made and distributed before Alexandria fell. Most of his other work didn't. The Library of Alexandria at its peak held an estimated 400,000 scrolls. Not just literature, technical manuals, engineering blueprints, astronomical calculations, medical texts, and mathematical proofs from across the ancient world. When Julius Caesar accidentally burned part of it in 48 BC, when Aurelian damaged it in 270 AD, when Theophilus destroyed the Serapeum in 391 AD, each event erased documents that existed nowhere else on Earth. We have no complete inventory of what was lost. We have fragments, references in surviving texts to works that no longer exist, descriptions of machines, formulas, and techniques that other ancient authors cited and are now gone. Hero himself referenced works by earlier engineers, whose manuscripts have never been recovered, which means what we know of ancient Greek and Roman engineering represents the fraction that survived, not the full picture. Some of what burned in Alexandria was almost certainly more advanced than what we recovered. We just don't know by how much. The Industrial Revolution began in England in the 1760s. It transformed human civilization within a century, mechanized agriculture, mass manufacturing, global trade, modern medicine, modern warfare, modern infrastructure. Hero of Alexandria demonstrated the core thermodynamic principle in 50 AD. That gap is 1,700 years. Historians and economists who have modeled alternative timelines estimate that an industrialized Rome, even a partial one, could have advanced human development by between 500 and 1,000 years. The implications are almost impossible to process. Diseases that killed hundreds of millions throughout the medieval period might have had treatments. Famines that shaped the collapse of civilizations might have been prevented. The Dark Ages, the centuries of intellectual regression that followed Rome's fall, might not have happened at all. One engineer, one device, one empire that looked at it and chose not to act. 1,700 years of consequences. Hero of Alexandria's steam engine is in the history books. It's not hidden. It's not classified. What's buried is the question it forces. If the most advanced civilization in the ancient world had this technology and walked away from it, not because they couldn't use it, but because the people who controlled the economy had more to lose than to gain, what does that tell you about how technology gets developed today? Who decides what gets built? Who decides what gets funded? And who profits most from making sure certain things never reach the market? The Invention Secrecy Act has 5,784 answers to that question. Drop a comment. What do you think Rome could have built if they'd actually used it? Next week on Tech They Buried, Stanley Meyer built a car that ran on water, turned down $1 billion, and died at a restaurant telling his brother he'd been poisoned. Subscribe. I'll see you there.